Next, we will talk about another interesting topic in relations, which is the equivalence relations. Before we start the topic, we need to know what is meant by equivalence relation. An equivalence relation is defined as a relation that is reflexive, symmetric, and transitive at the same time. We are given two elements named A and B. The elements A and B that are related by an equivalence relation are called equivalent. In this case, A tilde B is denoted. For instance, a relation R is defined on the set of real numbers as ARB. Given A minus B is an integer, is it an equivalence relation? According to the previous definition, an equivalence relation should be reflexive, so A equals to A. Since A minus A is equal to 0 and 0 is an integer in the set of real number A, ARA is denoted for all real numbers A, hence relation R is reflexive. Now, we will suppose that ARB. Since A minus B is an integer, then B minus A is also an integer, then BRA. The relation RBRA implies that the relation R is symmetric. Then we will suppose ARB and BRC. Since that A minus B and B minus C will be integers, it shows that A minus C will be also an integer. Hence, ARB and BRC will suggest a relation ARC. It will mention that the relation is transitive. According to the above explanations, since relation R satisfies all the conditions, then it is an equivalence relation. Equivalence classes will be another important component in equivalence relation. The set of all elements that are related to an element of A is called the equivalence class of the particular element, given R is an equivalence relation on set A. The equivalence class of A with respect to R is denoted by bracket A small r, which is shown as the first. In other words, if R is an equivalence relation on set A, the equivalence class of the element A is shown as the second one. Now, we will find out what is the equivalence class of number 0 with congruence modulo 4. The equivalence class of 0 contains all integers A such that A is congruent to 0 modulo 4. The integers in this class are divisible by 4. Hence, the equivalence class of 0 for this relation is shown as following. A partition of a set S is a collection of disjoint non-empty subsets of S that have S as their union, and it will only be formed if the conditions below are satisfied. The following set S is given. Is option A and option B the partitions of set S?